This video is about continuity on an interval, and we just discussed in a previous video continuity at a point. We're going to need that definition for this one. For this definition, we'll say a function is continuous on an interval if it is continuous at every number or point in the interval. So let's recall continuity at a point. Remember, there are three components to that definition, and so they all apply in this case. Basically, we're going to take an interval and say, well, an interval is made up of points, and so if every point in the interval is such that the function is continuous there, according to that definition, at a point, then the function would be continuous at or on, we should say on the interval. Now, that does beg one question. If we take an example of an interval where it's only defined at the boundary on one side, so let's suppose that we have an x-axis and some interval where the function is closed on the left but open on the right, then you may say, well, okay, hold on. At this point or this end point of this interval where the function is closed, how can we use the point definition for continuity there? Because that definition, as you may recall, had three components, and one of those components is that the limit as x approaches some value a of f of x must exist. But to define the limit as x approaches a, remember that assumes that we're approaching from both sides. So how can you approach the endpoint of an interval from both sides if that's a closed interval, right? There's nothing defined on one side of it. Well, that's where we need these other assistant definitions to come into play, where we can say a function is continuous from the right at a if the limit as x approaches a from the right of f of x equals f of a. Okay, so this is how we get around it. If the function is, let's say, defined on a closed interval and you can only approach it from one side, then we can say it could be continuous from the right. So in the case that I've drawn here, where you have some closed boundary, I'll just put a value a here where that boundary is on the left side of the interval. This would be a case where you might need to discuss being continuous from the right as you approach that left boundary from the right side. And that's where these definitions can help. Of course, you could have a similar case on the other side, and we'll say a function is continuous from the left at a if the limit as x approaches a from the left of f of x equals f of a. So that would be a case maybe where you have a closed interval and something on the right boundary of it. Again, I'll say we will see some examples in our next video when we discuss types of discontinuity, where we have to look into this, so where is a function continuous or not continuous? We're going to consider the point examples, the interval examples, as they relate in that next video.